Okay, so as in the last video we have discussed a little bit about lattice energy and the heat of formation, right? Heat of formation, we have discussed that when the reactants are in their actual stable state, right? They are in their own stable state. When they both react together, the product is formed. Along with the product, the energy is released, and that energy is what we call the heat of formation, right? And lattice energy was nothing but when we make reactants in the gaseous form and make them react together to form 1 mole of ionic compound, along with that the energy which is released is what we call the lattice energy. Right now we have discussed or we have understood the difference between these two terms, right? Now for example, this reaction is given here, right? Wait, let me copy this reaction here again so that I can explain you, right? Sodium is in its stable state is found in solid state, right? Chlorine is found stable in its gaseous state, right? Gaseous gas, right? And 1 mole of NaCl plus, here the heat which is released is what we call the heat of formation. Since reactants, the both reactants are in their stable state, right? They are not in the gaseous form, they are in their stable state. Now we need to calculate the lattice energy, right? Now we are going to find the lattice energy. For finding the lattice energy, we need to convert them into gaseous first, right? So we need, if we will be converting Na into Na in the gaseous form, we need to give the energy, right? And if we are giving the energy, we will gonna write positive sign. And what energy will be giving here? Heat of sublimation or energy of sublimation, right? So heat of sublimation, because we know that when solid directly converts into gaseous, that process is what we call the sublimation, right? So here solid is directly converted into gaseous, so we need to provide the heat of sublimation here, right? Now we need to remove one electron from it. We need to make it Na plus, right? We need to make it Na plus. In order to make it Na plus in the gaseous, we have already discussed about ionization energy, the energy which is required to remove the electron from the gaseous atom. Now see, sodium is already in the gaseous form, right? And the energy now which is required by this atom to remove the electron is what we call the ionization energy. So that will also take positive ionization energy, right? Ionization energy. Now see, Na plus in the gaseous form we have already got. Now we need to take Cl, right? Now we are going to take Cl. Now see, Cl is already in the gaseous form, right? It is already in the gaseous form. So what we will be doing here, there is a bond between them, right? Cl, there is bond between them. Now we need to break this bond, right? So here we need to give energy again, right? In order to make itself a lone gaseous ion. So here we will be giving it bond of dissociation, right? Or energy of dissociation. That too in the positive form. Energy of dissociation. So here we have provided it with the energy of dissociation, since we need to break the bond, right? We need to break the bond. That's why we have provided this with energy of dissociation. Now Cl is in the gaseous form, but we need Cl negative, right? In order to make Cl negative, we need to again, not again, however, this energy will be released, right? Because we know that when electron is gained by the gaseous atom, the energy is released, and that energy is what we call the electron affinity. So that would be of course negative since that is released, and this is what we call the electron affinity. Electron affinity. Electron affinity, right? Wait. Now see this Na positive. This Na positive will react with Cl negative both in the gaseous, state. They will gonna produce 1 mole of NaCl ionic compound along with lattice energy. This is what we discussed about lattice energy, right? Lattice energy is nothing but it is released. It is released along with the 1 mole of ionic compound when uh, any reactants react together in the gaseous form, right? In the gaseous form. Now see Na positive, it is in the gaseous form. Cl negative, it is in the gaseous form. They both reacted together to form 1 mole of ionic compound NaCl along with the energy released, and that is what we call the lattice energy, right? Now we were calculating the lattice energy, right? Now see what would be the heat of formation if I write the formula for it. Heat of formation would be, see, we have given this heat of sublimation, so plus heat of sublimation, right? And then we gave ionization energy, so plus ionization energy, right? Then we gave energy of dissociation, so plus energy of dissociation. See, now this electron affinity is released, so that we will take negative, right? Electron affinity. Again, lattice energy is released, so lattice energy negative. This would be the formula for, the heat of formation, right? This would be the formula for heat of formation. And if you need to find the lattice energy, so what would be formula for it? See now, lattice energy would be equal to plus heat of sublimation plus ionization energy plus electron no, not electron affinity, however, heat of dissociation, negative electron affinity. Now see, this heat of formation is positive here, when it will go it will be negative, right? So negative heat of formation. This would be the formula for finding the lattice energy, right? For finding the lattice energy. Now this is what we call the Born-Haber cycle. This is what we call the Born-Haber cycle. Born-Haber cycle, right? Born-Haber cycle, or you can write process. Born-Haber cycle is used to calculate the lattice energy, right? You can find heat of formation as well. So this was all for today. In today's video, we have discussed in very detail about Born-Haber cycle and how to calculate the lattice energy, right? When two reactants are in the gaseous form, they both react together, they form 1 mole of ionic compound along with the energy released is what we call the lattice energy. And heat of formation is nothing but it is released when some product is formed and when reactants react together in their stable state is what we call the heat of formation. And to find lattice energy, we have an process or cycle, and that process or cycle is known as Born-Haber cycle. Now you can actually find heat of formation as well. You can actually find lattice energy as well. So this was all for today.